They're the same as Pascal's triangle, okay? So now, we are going to look at this binomial expansion right here. We're going to look at this guy to answer these questions. So let's look at them. The total number of terms. Now we are going to always relate these where we can to n. Okay? So, n is this number right here. So what is n in this first one? 0. How many terms do I have right here? 1. What is n here? How many terms do I have here? Anybody see a pattern yet? So if n is 2, we have 3 terms and so on. So the total number of terms is always n plus 1. So if we're raising a plus b to the 50th power, we should have 51 terms in that expansion. Okay? Now, what is the coefficient of the first term? 1. What is the coefficient of the last term? 1. Now let's look at a's and b's. Let's look at the exponents and see if we can figure out what's going on here. So a to the first here, right? And then this is implied a to the 0. Because anything to 0 power is just 1, right? So it would disappear. If n is 2, the first term is a to the second. The next term is a to the first. And then an implied a to the 0. If this is raised to the third power, we start with a to the third, go to a to the, and then a to the 0. So what's happening to this guy as that first exponent as we go? Each term it goes down by 1, doesn't it? Does everybody see that? So the exponent of a decreases by 1 each term. Now look at B. What is B doing? It's doing what? It's increasing by how much each term? You see it? Look at this guy. B to the 5th, but there's no B here, so it's determined it's B to the 0 right here, okay? So B to the 0, B to the first, B to the second, B to the third, B to the 4th, we end with B to the 5th. So while the first guy's exponent starts high and goes down by 1, the second one starts at 0 and goes up by 1. So there's a pattern there every time. So exponent of B increases by 1 each term. Now, the sum of the exponents. Let's compare this to n. What is n right here? So this guy, it is 5. What's the total of the exponents here? There's only one of them, so it's 5, isn't it? What's the total of the exponents between these two terms?
5.
Oh, 4 plus 1 is 5. What is the total of the exponents between these two terms? Oh, here, 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 and what was n? So what's the total of the exponents for each term going to be each time? Whatever n is. So the sum of the exponent in each term is n. If one of them's 4, the other one must be whatever n is, whatever you have to add to get to n. So how do we expand a binomial? We use Pascal's triangle. That's first. So, I want you to notice something. If we're raising something to the third power, we use row 3, don't we? Raising it to the fourth power, we use row 4. Fifth power, you use row. So if we're raising a plus b to the sixth power, what row do we need? We need row 6. Row 6 should start what? What are the first two terms of row 6? 1, 6, right? So how can I find what else that row is? What are the terms for row 6? 1 what? 1, 6 what? One, 6, 15, 20, 15, 6, 1. Are you seeing where that's coming from? You get it now? Ah, she's got it. Okay. So 1, 6, 15, 20, 15, 6, 1. So 1, 6, 15, 20, 15, 6, 1. Now, it's row 6, so how many terms should I have? 7, yeah. 1, 2, 3, 4, 5, 6, 7. So I've got all the terms, all the coefficients I need, don't I? So now we're going to employ our rule about our A's and B's. So I'm going to take this first, and I'm going to take 1. And then I'm going to start A at the highest power it can be. What's the highest power A can be? 6. So B starts at 0, doesn't it? Then I'm going to take my next coefficient, which is 6. A goes down to what? And B goes up to? Next coefficient is 15. A goes down to what? And B goes up to? Next coefficient is what? 20. A goes down to? B goes up to? Good. Next coefficient is 15. A to the what? B to the? Yep. Plus 6, A to the first, B to the fifth, plus 1 times A to the 0, B to the sixth, right? Does everybody see how this pattern works? I have now very quickly, don't you wish you knew this when you were multiplying all those things together, like, 2x plus 5 to the fourth power or something? You don't have to do it anymore. You can just use this pattern and boom, it comes right out. I'll show you how. Now, what about b to the 0 and a to the 0? What is anything to the 0 power? 1. So this guy pretty much disappears and this guy pretty much disappears, doesn't it? So we end up with our final answer is a to the 6, 6a to the 5th b, 15a to the 4th b squared, 20a to the 3rd b cubed, 15a squared b to the 4th, 6ab to the 5th, plus b to the 6th. And that's our answer. Now, let's try one more together. Make sure you've got the pattern. And then I'm going to make you try one on your own. So step 1, tell me what row do you need of Pascal's triangle. What row do you need in this guy? 7th. So find the 7th row. You've got it up to the 6th row, don't you? By the way, guys, I am not going to give you Pascal's triangle on the test. You're going to have to create it. It'll be one of your questions. Oh, guys, it's easy. What's at the very top? 1. What's the next row? 1, 1. It always starts with a what? A 1, ends in a 1, and then you add terms to get the middle things, right? So what is the seventh row going to be? Okay. Okay? All right. Now, I want you to try writing this out with A's and B's. I know it's an X and a 2, but I want you to do the A's and the B's on your own. So the first coefficient is 1, isn't it? And we're going to start A to the what? And B to the, which marks out, doesn't it? All right, true. What would the next term be? What would the coefficient be for the second term? Okay. A to the what? B to the? Amanda, what's the third term going to be? A to the what? All right, so keep going and get that all written out, and then I'll show you what you do next. All right, so check it. Did you get your AB expansion correct? All right. So no, we don't have A's and B's in that expansion though, do we? We have an X and a what? So guess what we do? Hey, quit it. This is A, and this is B. So everywhere I have an A in that expansion, I'm going to plug in a what? An X. And everywhere there's a B, I'm going to plug in what? No, a 2. So this becomes 1 times X to the 7th, 7X to the 6th, 2 to the 1st, 21, X to the 5th, 2 to the, and so on. All right. I know, it looks like a lot of numbers, doesn't it? I just straight subbed in, guys. At this point, it should be a calculator problem. 1 times X to the 7th is just X to the... So now, in the second part of this, what am I going to do? I'm going to say 2 to the 1st is what? Times. So what's 2 to the 1st times 7? 14. So this becomes plus 14x to the 6th. Calculator problem again for this term. 2 to the 2nd times 21, right? So what do we get? 84x to the 5th. Finish it out. Use your calculator and finish this out. All right. Here it is. Hallelujah. What?
How do you tell what the original coefficients are going to be if you don't have the line of triangle above it?
Well, you start with 1 here, and you create the triangle.
Oh, so if I'm doing this on the test, I would have to create the entire triangle down to row 7? Oh.
There's actually a way you can do it on your calculator without that, but it's actually easier just to create the look. 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1. No, but you can add. You're not, it's not like I'm asking you to add great big numbers. 1, 6, 15, 20, 15, 6, 1, 1, 7, 21, 35, 35, 21, 7, 1. I'm already down to row 7.
How many rows are we going to need to make?
I won't ask you anything past like row 7 or 8 because I don't want you to waste your time having to, and I'm going to ask you to create Pascal's triangle for like 9 rows or something, 8 or 9 rows. The very first question on the test will be create Pascal's triangle for the first however many rows. And you'll have to do it. And then guess what? You have it. So you need to be able to get this pattern. Do you know what everybody misses the most? Do you know which row everybody misses?
The second row.
The second row.
Yes.
What do people put for the second row?
They don't. They skip it.
Oh.
And then it throws them completely off. I'm like, I don't know how you skip it if you know the pattern. Because 1, to go from 1 to 1, 2, 1, it doesn't work. 1, 1, 1, 1, 2, 1, and so on. But you are absolutely correct. Second row is the one everybody forgets. All right. So I'm going to put the rest of this in so you can check your work. So if you got it right, good. Hopefully. See, this is not as bad as you thought. You were all like, oh my gosh, this is going to be terrible. Look at all those numbers. It's not that bad, is it? Once you see the pattern, not too bad. You do these, it does. It just takes a little while. There aren't very many of them in your homework. There are only about 5 of these that I'm going to make you do in your homework. We're going to try one more. But you do need to do all 5 of those because if you don't practice this, you won't remember it. And then you're going to flunk it when I give you the test. 1, 1, 1, 1, 2, 1. It's really easy on paper. Yep. All right, so let's try this one with the negative. I want you to try this one all the way from the start by yourself. Which row are we doing? Row 4. So what is row 4? 1, 4, 6, 4, 1. You know how you don't make a mistake and start counting at row 1? Remember, the top of the pyramid is row 0, isn't it? All right. So row 4 ought to start 1, 4. And it should have 5 terms, shouldn't it? So now do the expansion with A and B, and then plug this in for your A, and plug this negative 1 in for your B. So negative 1 is B, and 3M is A. So double check and make sure you got your AB row right, and then plug in. Now, do you know where people make mistakes here? Not the sign. Believe it or not, they don't make a mistake with the sign. They make the mistake when they're raising 3m to a power. Like for number 1, for the first term, I often get 3m to the 4th power is the answer. That is incorrect. That entire term is being raised to the 4th power, isn't it? So that's like saying 3 to the 4th power times 1 times m to the 4th power. So when you're putting these in your calculator, which it is just a calculator at this point, you should be doing 3 to the 4th times 1. 3 to the 3rd times 4 times -1. 3 to the 2nd, -1 to the 2nd, 6. 4, 3, -1 to the 3rd, right? 1, -1 to the 4th. Just throw it in parentheses. Make sure you get those negatives in parentheses, okay? And then write it out and check your answer. I'm gonna put the answer at the bottom so you can check yours. Okay? Make sure you can get that. If you didn't get it, then raise your hand and let me come help you. Desiree, I love the blue, by the way. That's fab. So how'd we do? Are we feeling fairly confident about this? Good. All right, so let's do the second half of this lesson, which is, can we find any individual element in Pascal's triangle? The answer is yes, you can, and it's not that hard. There's a formula for it that looks complicated, but we're not going to do it complicated. If we have an nth row and an rth element, rth element, then what we know is we can find the coefficient by doing a combinatorial, NR. This right here is this. I don't even care if you know that because you're going to use your calculator. Hit the math button on your calculator. Hit math. Now, arrow over sideways to probability along the top. Oh, about 3 down, you see this, don't you? NCR. Combinatorial. P is permutation, C is combination. It is the number of possible things. N is the number of possible things, and R is the possible combinations you want out of it. But N is the row, and R is the element, okay? So literally, if we have 6th row, 3rd element, that is 6, 3, which is 6 combinations of 3 each. 6 elements, combination. How many combinations of 3 can we get out of that? And that would be what that was. Throw it in your calculator and see what you get. Yep, you get 20. Try one more. Try say 3. 18th row, 2nd element. Pretty easy, isn't it? All right, guys. What the cool thing is we can use this idea to actually find the coefficient of an individual term. You were asking if there was some way to find them without using Pascal's triangle. This is how. You can find the individual elements if you want to use your calculator. Now, we have to remember that term is not element. It gives you the 8th term, then what it's asking you for is the 7th element. Because this is the R plus 1th term. So R is going to be 1 less than that element. Okay? So what is N? A plus B to the 10th power, we want the 8th term. So what's N? 10. So this is going to be N. And this is going to be R right here. It's going to be the term minus 1. So this would be 8 minus 1, which gave me 7. So we're going to use 10C7. And what is 10C7? 120, isn't it? 120. That is the coefficient. Now we need the rest of the term. Well, take a look over here and see what you've got. This is what you need to know. It is going to be A to the N minus R, B to the R. So if you know N and R, you can find those, can't you? So N minus R, B to the R. So this would be A. So we have 120, A to the N minus R, B to the R. So what is 10 minus 7? So we get 120, A to the 3rd, B to the 7th. And what did we say that the exponents had to add up to every time? N. So 3 plus 7 is. So let's try one more of these together, and then you can do it on your own. So we want, first thing you have to list is N and R. What is N for this guy? 12. What is R? Good. It is term minus 1. So R is 2. So if we're going to set this up, we are going to do N, C, R, A to the N minus R, B to the R. Right? I literally just copied that from this and plugged in numbers. So this is my A, and my B is -7, isn't it? So now I'm going to do 12C2. What is 12C2? 66. So this becomes 66. A is what? To the 10th. And B is -7 to the 2nd. So we can come up with an answer. See how it works? So just do -7 squared times 66. And what do you get? X to the 10th, right? All right. So why don't you see if you can do this with number 8? Follow the lead. List your N, list your R, and then plug in. Do your A-B form and then plug in for A and plug in for B. And see if you get the right answer. List N, list R, and plug in. So did you get the right answer? Yes? Great. So is everybody clear about how we do this part? Seems pretty easy, doesn't it? This is all just plug and chug. All right. So let's skip over to the binomial theorem. The binomial theorem basically says that you can find any term, coefficient in the front, by running this formula. NC0, NC1, NC2, NC3, all the way until you get to N. Now, this is the same thing we're doing. Basically, this is creating the terms for Pascal's triangle. Okay? Now, my thought on this is we just learned how to do this with Pascal's triangle. For most cases, 6, 4, whatever, 7, 5, wouldn't it be faster, rather than having to throw these through your calculator over and over again? Do you know what my recommendation is? Do it with Pascal's triangle like we did before. Don't use that combinatorial. In other words, guys, this is 0C0. This guy right here is this is 1C0. This is 1C1. This is 2C0, this is 2C1, this is 2C2, and so on. See what I'm saying? You can find them all. This would be 3C0, 3C1, 3C2, and 3C3. So you can find them doing that, but why would you do that? Do you see how fast it was for me to, it'd be fast for you to write Pascal's triangle out than it literally would be to throw all these through your calculator to find the terms. Now, if you had to find like the 13th row, you could bet your bucks I'd be using 13C0, 13C1, 13C2, 13C3, because I don't want to have to do 14, row 13 of Pascal's triangle. Those are going to be pretty big numbers, aren't they? Yeah. But for anything like 5, 6, 7, create Pascal's triangle and do it the way we did before. Okay? Does everybody get that? I know. That's what I'm saying. So does anybody have any questions about how we do these? Use Pascal's triangle. You don't have to use binomial theorem. When you use Pascal's triangle, guess what? You are using the binomial theorem. You're just using it in your brain instead and looking at the patterns instead of clunking things through a calculator. So, homework. You do have to do, which is 4 through are simple one-term things where you just have to plug in that formula. So you have 9 easy problems and 5 expansions. You don't have to do every one of them except, now I noticed there were like 7 of these really long problems, so I decided to be nice to you and get rid of 2 of them. You do not have to use do 13 and 16. So that leaves you with 5 binomial expansions, and the rest of these guys should be pretty quick. Notice that the bulk of your homework, what, 12? That's 9 problems, 13 and 16. Okay? I felt like that was fair. This is the last section in this unit. We only had 3 sections, guys. So guess what we're doing on Thursday? Reviewing. Now that would put your test on Monday, so I'm going to be nice to you and not give you a test on a Monday. I am going to give you a test next Wednesday, and so Monday we are going to be reviewing complex number operations because we're going to be starting complex and polar next. Now, we have complex and polar numbers. We have matrices and vectors and parametric equations, and limits. So we have 3. Limits is super short though. Limits is like 2 days. And then you get to take calculus. By the way, if you didn't hear, you weren't here when I was talking to one of